Erasm is a small company which perform RAMS analysis, which is safety, availability, reliability, and maintainability analysis, and we support company to build their safety demonstration, and we support the company till the certification of a product. So next, so. Since many years, the accident rate of different in the railway, in the European railway, the accident rate is decreasing, and we, thanks to the use of electronic devices and some monitoring system that are implemented in the different locomotive or so rail track and so on. So what's the effect of this system is that we need context and standards to use it safely, and then we we have now a lot of standards that mainly are presented to system, hardware, and software. So the three main standards are the 5126, 5129, and 5128. So one is dedicated to RAMS analysis, and the other one to hardware, and the third one to software. What is specific to this standards is that the 5128 for software is relies more on the control of the process of the production of the software, and so the verification and the test strategy and the elaboration of the documentation. And the 5129 is more dedicated on the mastering of the random failure that the hardware, the component hardware, can bring to the board or the system of signaling of the embedded computer. So, and the 5126 is dedicated to the RAMS process. So, how the RAMS analyses are built for and how they are linked together to bring a safety demonstration for the whole system. Okay, next please. Okay, now the new actuality is that a new TS50-701 is is released for some some European country, and this new TS is dedicated to cybersecurity, as we talked about in the already done presentation. Okay, this TS will bring some new certification, what is done by what we call EK, Independent Cybersecurity Assessment. Like the already organism that perform ESA Independent Safety Assessment, there is a new domain that is the EK, Independent Cybersecurity Assessment. And this new accredited organism can also bring some certificate for the VSTS. So it's a new, I think the new project of 2022 will need to be concerned by this TS and this EK certification. Next, please. Okay. The other fact is we are in a European country, and so there is now some technical specification for interoperability. Technical specification of interoperability is used for to the country to build system that can be exchanged by between country, and so to perform a certification about to be sure that one system is able to talk with other one. There is some certification body that is not now called notified body, and these organisms are able to deliver certification to comply with that the system are able to interoperable with each one. Okay, but system that can be interoperability for in a European country, the different system can support also safety functionality. So the NOBO is not able to guarantee that is able to evaluate the safety aspect of this system, and for the safety aspect which link to interoperability, there is another notified body what is called assessment body. This assessment body will check that the system is safe regarding the level of required by the TSC. And then, okay, as there is some specificity for each country. There is some specific technical specificity to run the system in each country, and for this specificity, you have another organism that is the DBO, designated body, that is in charge to assessment of a project according to the national rule. So there is different organisms that often are the same company that is able to handle all this aspect. Next. Okay. Now we have a specific organization for the critical system. Specific organization is that activities shall be independent from the design and the project. So conception, development, and design, safety and security conception are different from the verification and validation. Verification and validation can be independent or dependent depending on the skill level you require for. Verification and validation are activities that will guarantee that the conception is safe, but the development, the design shall be designed for the safety. So design and design team and the conception team shall design their system for safety, and is not only the responsibility of the safety to demonstrate the safety of the system. Okay, at the end, all these activities shall be resumed, sum up in what we call a safety case. Safety case is the demonstration, is the written demonstration of all activities, all process has been clearly performed to demonstrate the safety of a system. And an independent safety assessor will bring his opinion and for the certification by an independent organism. Next, please. Okay. What kind of method we are using in safety and security? Well, most of the method relies on the same strategy, the assessment of the qualitative impact, the assessment of the likelihood, the frequency of occurrence of each event, and the evaluation of the impact of the undesired events, like doing a cross matrix. We also perform V&V activities, that's safety and verification and validation activities, or cybersecurity and verification and validation activities. Well, when the design as performed is design in safety and in cybersecurity and for protect the equipment. The VNV activities are done to verify that all the requirements are set established correctly and they are can be demonstrated through all the data furnished by the design. Okay, as we mentioned before, all the data will be collected through a unique document, which is a safety case and security case. Our safety case can be built if there is a system is not linked to security case, to cybersecurity aspect, but a security case can be also performed if there is only concern to security. Next, please. Okay, what we can find in the different standards linked to safety and to cybersecurity. Here is only safety, but is the same strategy. You have some documentation or requirements and methodology that are allocated to each safety integrity level, or the document and the methodology or measure shall be done depending on the safety integrity level. As we can show, there is high recommended safety document or recommended design measure and so on, till mandatory that combination of measure and documentation shall be done. Next, please. Okay. Well, this is for just to underline that the safety cannot be done only by the safety teams. Okay, the management and the implication and the promotion is a key factor for the safety. Designing and the design team shall perform and design for safety, and the safety team will bring the proof that the safety is performed, not made the design for the safety. Okay. If the design team is not implied in the safety, well, what we saw is that the planning and the performance of a system are not very well. Next, please. Okay, this PowerPoint is to underline that seal level, which is concern the process to avoid what we call systematic failure. Systematic failure are failure linked to the process, that requirements may be not taken into account, or the requirements that are not clearly enhanced. And okay, seal process is not a THR. THR is how the probability of failure are assessed or evaluated. So we cannot perform a seal level and a THR independently. We have to perform all of us to reach a safety system. So the THR is evaluated on hardware, and most of the time the seal level is the process that is put in place to build the safety and develop the project. All activities, design, verification, and validation are need to comply with standard and safety requirement. So what we see in some project, that some activities are not clearly done, like verification or validation. Some part of quality aspect are not performed. So at the end of the day, this activity or this will be mentioned by the certification, and so it will be some ECAR or some remarks from the certification that will be done at the certificate. So next one. In the new 5109, 29, the new Annex F is an informative one, but is dedicated to what is written like EPIC for FPGA and so CPLD and so programmable component. This is a new annex that define a new process for this kind of component, programmable component. That okay, the program to develop this kind of component is equal to a development of software. So we find some maybe the same document to be done for the programmation of this EPIC and as for software. Next one, please. For software, what we see is that a stack of different programming tools. Okay, what we see is that for the development of software, we have some now the use a lot of tools that bring some new rules to the process. So, and these tools need to be taken into account for safety point of view, because these tools can bring some errors in the programmation, and so these kind of tools need to be qualified, and some tests and some specification need to be done, or some certification need to be done for the use of this tool, and it has to be considered in the certification of a system. One other point is the interest of segregation. If you have the different software or C-level software, safety and non-safety, is very interesting to segregate these two types of software. Most of the time, non-safety software are linked to maintainability or to maintenance aspect. So the strategy will be more to use another microprocessor that support this kind of software than to mix the non-safety and non-safety software. So it's a very important cost of reduction, because non-safety software have a lot of functionality and a lot of bibliotheques that are used to build them. So if you don't segregate safety and non-safety software, you will have to perform all the analysis at the same level, the worst level, like SIL4 or SIL2, or to all the software. And a last table that is based on the aeronautic experience, that show how much line of code can be produced depending on the safety level. Safety level like DAL-D is like SIL2 in railways, and DAL-A is like SIL-CAT in railways. And so we can see that the production of a line of code without or with experience, and depending on the safety level, is very low. If you see we want to perform a SIL4 development without experience on the, you will see that you are just on the metric of 3 lines of code by day, which is very, very, very low. Okay, and next one, please. Okay, for software, the new a new amendment has come out, and we see that for this new amendment, the effort has been done to integrity, what we call integrated basic integrity, and for this level, the basic integrity level, the documentation has been lighted, and the production of the documentation need for basic integrity is now very low. Next, please. System safety case. Safety cases are split in three aspects. Three type of document. What we call generic product safety case, which is dedicated to a product. Generic application safety case, which address an application that is common to several projects, and specific application, what is address specific data for configuration. As we can see, there is different safety case for different strategy and for different products. And what is used to be able to use different products, safety certificate product, is that safety-related application condition, as like our export requirements that are used to indicate or to oblige the user to maintain safety continuously through the utilization of this product. Next one, please. Okay, and the last PPT is for indicate that safety case now interesting in the physical security and IT security. The IT security should be addressed by the TS that defines specific cyber security case, and the physical security is not addressed by the standards. Physical security is how you could log in and how you can access to the different aspects of software or the system. Okay, that's all. Thank you.
Well, thank you very much, Christophe.